Hello and welcome back, everyone. We're looking at a problem today: find smallest letter greater than target. It is considered an easy problem, and I think easy it's considered the O of n time, but if we want to do better than that, I think it's a little bit more challenging. But let's see how we would do that. So let's understand the problem first. We're given a char array of letters and the target, and we want to return the smallest character in the array that is larger than the target. So in this case, if our target is A and this is our letters, we'll just return C just because C is larger than A and is the smallest largest element than A. And our input consists in lowercase English letters. So how would we do this in a better time than O of n? And this question is tagged under binary search, and it just proves one more time that binary search is such a cool topic and you could apply it on so many things. For example, this problem. So let's take exactly a look at this example. We have letters which is C, F, J, K, P, and Y, and we're looking for target M, and we want to return the largest and smallest element in the array. So when they're saying largest and smallest, so for example, we know that if it's largest, since this is a sorted array, it needs to be in the right, and if it's smallest, it needs to be the first one that we find on its right. So let's think about some base cases first. How do we think about if, for example, if our target is Z, what would we return? So if our target is Z, all we have to do is return the first element, right? Because there's nothing on the right of Z, so we'll just return the first element. What about if our target in this case is A? What would we return in this case? So if it's A, all we have to do is just return the first element in the array, because there's nothing in this array left of C, and our target is less than the first element, so we could just return the first element in the array. So we see there are two cases, first of all, for which we will return the first element in the array. If our target is greater than my last element right here, I'm just going to return C. Or if my target is less than my first element, I'm also going to return C. I think it's fairly helpful to imagine that this array is like a circular array. So if you have something in here, you can go and look for the element at the beginning of the array. All right, so with that being said, let's see how would we apply binary search in this problem. We know that in binary search we have our left, right, and mid pointers. So let's do exactly the same thing. Our left is 0, our right is 5 in this case. Let's compute the mid, and our mid will be equal to 2. So this is our mid right now. Now what we have to do is compare this target, which is M, compare it with the element of our mid, compare it with J. So what do we see here? How do we see, is this M less or greater than J? So we know that this M right here is greater than J. So because of that, we're gonna disregard basically this part of the array. We're not gonna look in this array anymore because we know our answer needs to be somewhere in here. So what we can do right now is move our left to M plus 1. So our left will move to 3. So our left initially was here, and now our left is moving here. This is our new left. Now do exactly the same thing. Our mid becomes 4 right now. So we're comparing M again with element at 4, which is P. So we know that this is less than P. M is before P. So we're gonna move our right. This was initially our right, and now we're gonna move it to M minus 1. So our right will also become here. So our right becomes 3 right now. And now we're running this condition while our left is less than or equal to our right. So we have one more iteration of the loop. So right now 3 and 3, our mid is also 3, and we're gonna look at element of 3, which is k. So we can see this m is also greater than k. So we're gonna increment our left one more time to m plus 1. So our left right now is going to become 4. And all we have to do at this point is we have to compute the mod between our left and the total number of elements. So 4 mod 6, it'll give us 4, and then we'll just return the element at that position, at this position, which is P in this case. So this is our answer, the final answer. So let's see how will this look in code super quick. Let's get to Leetcode, and we said we have two conditions at first. So if our target is less than letters of 0 at the beginning, so if that's the case, or our target is greater than letters, or let me just get a variable int n equal letters length, so we don't have to call this again. So if our target is less than letters of 0, or a target is greater than letters of n minus 1, all we have to do is return the first element in our letters. So all we'll do here is return letters of 0. So now we're gonna go ahead and create our pointers. Left equal to 0, int right equal to n minus 1, and our while loop, while left is less or equal to our right, do the following. And we said we're gonna get a mid, which will be left plus right minus left, everything divided by 2. And then we're gonna make our two checks. If our target is less than our letters of mid, then what we have to do is move our right pointer, right? So right equal mid minus 1, else, which is the opposite scenario, left is equal to mid plus 1. And all we have to do at the end of this loop, we'll just return letters of our left pointer mod n. Oops. Mod n, and that should be it for this problem. Let's try to run it. Oops, I have a condition here. On my left is equal than right. Perfect. Perfect, and it's been accepted. That's it for this problem. Thank you so much for watching, and I'll see you in the next video.